Alright, so there's no entry task today because we have the quiz. So I'm just going to run this Explore with you a little bit, just in case you need another clarification after class or during class. So let's take a look. It says you have a kit, and I made mine out of graph paper right here, but yours is this. There's a circle and a cover, okay? And then you have squares that are in the cover as well. Alright, so that's what it says. And you have a pair of scissors, because you'll need those. Okay. So if we take a look, it says here we need to find out another way to say what these squares are. So let me take a look at these. These squares, okay, center this here. These squares are special because compared to the radius, here, do you see that's the center of the circle? And I drew the circle using the compass so I can see that point is the center. This is exactly one radius distance on this side. R for radius, and if I turn it, it's a square, so again it's another radius on here. So this represents r squared, okay? And each of these pieces are the same, so I'm going to put r squared on all of them. Okay. You don't necessarily have to mark all of yours in your box, and as the period goes, the day goes, probably some people have already used some of these pieces. So let's just see here. It says, so let me just fill this in here. So what is another way to say these squares are? They are radius squared. Alright, how many squares can we fit in the circle? And yes, I said use the scissors, so let's take a look. Okay, let me get this one in here. That one looks like it gets kind of cut off. Let's trace a line there. Okay. Alright, and maybe I'll fit this one over here. Alright, now it's going to start getting messy. So I have, here's the three parts. Let's see here. Maybe I'll say that if I cut this, that's going to fit there, and that looks pretty close there if I just add a little bit more. That's that. And this looks really close there. Okay. Sorry, do you see that I almost cover up this whole space with three pieces? I could put this fourth piece in, but it doesn't look like I need very much of this. If I was actually to calculate it out, so I'm going to say a little bit greater than 3. Maybe I'll put 3.1. Okay. So let's take a look. I'm hoping this is ringing a bell because we've already talked about pi once. Pi is 3.14. Do you see that? This right here, this is pi worth of radiuses squared. There are 3.14. If I spread them all out evenly, they actually fill it up. Okay? Which is kind of crazy. So that means our formula means we take whatever the radius is, and we square it, and we times it by pi. This is because it takes that many radiuses times 3.14, and that's how we get the rate for the circle. So let's actually apply it. It says here, let's find the area. So it says the radius is 12, and we know our new formula is this. Put equal there. So we've got 12 squared equals times pi equals area. So let's just try it. 12 squared is 144 times pi gives us 452.39 inches squared. Okay, let's do the other one. I'll give you a second to do that. Just as a comment, please don't use the 3.14. Use the pi button on your calculator. I got 615.75 kilometers squared. Alright, I wish I'd given a little bit more room for these on the bottom. These ones, we have the area, so that means we have to work backwards. So if I'm going to write our same formula, area equals pi r squared, which we just figured out, 201.1 equals, because that's the area, equals pi r squared. Alright, we only have one variable, so let's divide both sides by pi. So 201.1 divided by pi. Maybe a second to catch up. That gives us 64.01 equals radius squared. And our final move, if we Think about Pythagoras the last time we did this. If we have a number squared, we just take the square root on both sides to get the answer. And I can tell this is super close to 64. Square root of 64 is 8. So the radius must be 8. And that's how we solve these.